My name is Hao Zhen. Let me briefly introduce the programming parts of our project. There are two parts. The first part is sending emails, and the second part is chart construction. This is the code for the sending parts of the email. The sender information is sent here using Google Mailbox, and then the school's ASU mailbox is used for receive the email. Um, here is where to fill in your Google email address and password. The content of here is the content of the mailbox body. The first parameter is the content. The second parameter is the format, and the third parameter is the encoding. Here is the sender, the receiver, email, send, field link, login, send email. Finally, final is shut down the server. This is the second. This is the second part of the code, which is contains the function of converting the data into charts. The code imports the matplotlib package called the port library function, creates the figure sets the x-axis to the time, then the y-axis to TDS and the water distance, and then manually passes in the parameters to generate the chart. This is what I get when I put the parameter into the code as shown in the picture. Thank you.
So I'm just going to quickly go over how the ultrasonic sensor measures distance and how that's going to be able to measure the water level and store it, and store the history of that sensor. So you have this function called measure dist, and essentially what it's going to do is it's going to send a signal to the sig pin, and it's going to measure the distance by how long it takes for it to receive a high and a low, and between that and then another high and a low, and then it's going to send that back to this function here, and this essentially converts it into inches, and the then that data can be stored as a text file in this function called append history, and then that can be sent to a website using Python script and Firebase. You need to have a TDS meter so that you can measure the amount of grow solution that's left in the water and make sure that the plants, basically still have food, and that they're not just sitting in plain water. And so what I'm showing you here is there's this equation that'll read the voltage from the signal pin, the in the yellow wire, and it's going to put it into this kind of long, complicated equation where it multiplies it. So it's the compensation voltage is getting multiplied by 133, multiplied by itself, minus 255 times, and at the end of it, you come out with a reasonably accurate TDS measurement. You can see and this hooked up in here, and I'm going to demonstrate if you pour a bunch of let's just say salt into one liquid, it should increase the TDS significantly, and that's going to be kind of similar to our grow solution, and I'm going to demonstrate. So you can see it's reading 0 parts per million, and then if I just do the plain water, it starts picking up, and it's reading about 480, 490 ppm. And then if I use a handheld TDS meter and I just stick it in the water, let's see. You can see it's not perfect. They are slightly different, and part of that has to do with where they're placed in the water and other factors like that. But they're reasonably close. And then if you stick it into the salt water, you should see a significant increase here. So you can see we're getting about 1150, 1160 parts per million, which is a very significant increase. There we go. And then you could see on here, oh boy. This is difficult. At the top, where it was measuring just like the other one, you can see you're getting about 1400 or so